Even with healthy seeds, proper irrigation, and balanced fertilizers, sugarcane cannot achieve its full potential if it faces competition from weeds or damage from pests and diseases. Weed management and pest control are therefore critical components of a successful sugarcane crop. Weeds are unwanted plants that compete with sugarcane for sunlight, water, and nutrients. Left uncontrolled, weeds can reduce sugarcane yields by 20 to 40%, especially during the early stages when young sugarcane shoots are still weak. Some common weeds include grasses such as nutgrass and Bermuda grass, broadleaf weed like morning glory, croton, and amaranth, and sedges such as cyperus species. The type of weed often depends on soil type, climate, and previous crops. Farmers use several methods to control weeds. Manual weeding involves hand pulling or hoeing, which is labor-intensive but effective for small fields. Mechanical weeding, using tools or tractors with harrows, is suitable for large-scale farms and saves time and labor costs. Chemical control through selective herbicides is also used. Pre-emergence herbicide prevent weed germination, while post-emergence herbicides control growing weeds. Safety precautions should always be followed to avoid crop damage or environmental hazards. The most effective approach is integrated weed management, which combines cultural practices such as proper row spacing, mulching, and crop rotation with mechanical and chemical methods to reduce labor, cost, and long-term weed problems. Sugarcane is vulnerable to several pests, including sugarcane borers that tunnel into stalks, white grubs feeding on roots, aphids and mealybugs that damage leaves and transmit diseases, and termites attacking roots and young plants. Farmers must regularly monitor pest presence and take timely action. Pest control methods include cultural practices such as crop rotation and removal of crop residues, biological control using natural predators like parasitic wasps and predatory beetles, chemical control with insecticides applied at the correct stage. Integrated pest management that combines all these strategies for long-term suppression. Signs of pest infestation include holes or tunnels in stalks, discolored or curled leaves, stunted plant growth, and visible insects on leaves or stems. Early detection and intervention prevent large-scale crop losses. After proper planting, irrigation, fertilization, and pest management, sugarcane enters a series of growth stages that determine its final yield and sugar content. The first stage is germination and sprouting, lasting about 0 to 30 days after planting, when buds in the set start to sprout and young shoots emerge from the soil. During this stage, adequate moisture is essential for germination. Weeds should be removed carefully, and seedlings must be protected from pests like termites and cutworms. The next stage is tillering, occurring around 30 to 120 days after planting, when multiple shoots or tillers develop from each set. Strong tillering leads to a higher number of stalks. Key maintenance practices during this period include split applications of nitrogen fertilizer, proper irrigation, weed control, and pest monitoring. The grand growth stage follows, lasting roughly 120 to 240 days after planting, characterized by rapid elongation of the sugarcane stalks and maximum uptake of water and nutrients. Consistent irrigation, potassium and micronutrient application, and timely weed and pest control are essential at this stage. Finally, the maturation stage, which occurs around 240 to 360 days depending on the variety, is when stalks harden and sugar content increases. Growth slows. Irrigation is gradually reduced, excessive nitrogen is avoided, and late-stage pests are monitored. Throughout all stages, intercultural operations such as earthing up, top dressing, fertilizers, and irrigation adjustments ensure a healthy, uniform crop. After months of careful planting, nurturing, and growth maintenance, sugarcane reaches maturity. Harvesting at the correct time is crucial for maximum sugar content and yield, as cutting too early or too late can reduce profitability. Farmers determine maturity by observing stalk hardness, color changes depending on the variety, leaf shedding, and the thickness of internodes. Some also extract juice from a sample stalk to check sucrose percentage. Generally, sugarcane is ready for harvest about 10 to 14 months after planting. Harvesting methods include manual cutting using machetes or sickles, which is labor-intensive but precise, and mechanical harvesting for large-scale farms, which is faster but requires careful handling to avoid damage. Best practices include cutting canes close to the ground, trimming leaves, avoiding damage to stalks, and transporting harvested cane quickly to prevent sugar deterioration. Post-harvest, leftover stubble should be removed, organic matter applied to restore nutrients, and pest and disease carryover monitored to ensure healthy regrowth. Delayed harvesting, cutting too high, rough handling, or leaving harvesting cane in the field too long can reduce yield and quality. After harvesting, the harvested cane must be transported to the factory as quickly as possible because sucrose content begins to deteriorate immediately after cutting. Timely and careful transport ensures maximum sugar recovery and reduces financial loss for the farmer. Transportation methods vary from traditional bullock or animal-drawn carts, suitable for small or remote farms, to trucks and trailers for large-scale farms, and tractor trolleys for medium-sized operations. Some industrial setups even use conveyor or ropeway systems to move cane continuously. Proper loading is crucial. Stalks should be stacked without crushing. Overloading must be avoided, and ventilation should be maintained. Covering the cane during long transport protects it from sun and wind. Minimizing transit time, coordinating harvest schedule with delivery, using multiple vehicles, and choosing smooth routes are important to prevent sugar loss. Proper handling, such as avoiding dropping or throwing cane, keeping it clean, and maintaining vehicles further ensures cane quality. Delays, overloading, sun exposure, or poor coordination can all reduce profitability, making transportation a critical part of the sugarcane supply chain. After the harvested cane reaches the factory, the sugar production process begins. The first step is crushing, where the cane is fed into large rollers to extract juice. This juice contains sucrose along with impurities such as fibers, soil, and other particles. The extracted juice is then clarified using lime and heat, which removes impurities and results in a clear, sweet liquid. This clarified juice is concentrated through evaporation, where water is removed to form thick syrup. The syrup is further processed in crystallization units, producing raw sugar crystals, which are separated from the remaining molasses. Finally, the raw sugar is dried and packed for distribution, completing the transformation from field-grown cane to refined sugar ready for consumption. While the factory works on processing, farmers begin planning for ratoon cropping. After the first harvest, the remaining stubble and roots in the field can sprout again to produce the next crop, known as the ratoon crop. Proper field management is crucial at this stage to maintain soil fertility and prevent pest carryover. Farmers apply organic matter, check for any leftover weeds, and monitor for pests and diseases to ensure the ratoon crop grows healthy and productive. This cycle allows farmers to maximize production without replanting entirely, reducing costs and labor. Modern sugarcane farming also emphasizes mechanization and efficiency. From mechanical planters and harvesters to modern irrigation systems like drip irrigation and fertigation, technology helps farmers save time, reduce labor, and improve yield. Machines ensure uniform planting depth, timely cutting, and efficient water and nutrient delivery. When integrated with traditional knowledge, mechanization supports higher productivity, better quality cane, and more consistent sugar content. benefiting both farmers and factories. Economic aspects play a significant role in sugarcane cultivation. Farmers invest in quality seed cane, fertilizers, irrigation, and labor throughout the crop cycle. Proper timing, crop care, and pest management directly affect yields and profits. Market demand and sugar prices also influence planting decisions and variety selection. Efficient management, timely harvesting, and proper transport to the factory ensure farmers maximize their return on investment. Sugarcane is not just a crop, but a key livelihood source, providing employment and economic stability to millions. Looking forward, the future of sugarcane cultivation lies in sustainable practices, research, and adaptation. Improved varieties resistant to pests, diseases, and environmental stresses are being developed. Water-efficient irrigation methods, integrated nutrient management, and precision farming techniques help conserve resources while maintaining high yield. Education and training for farmers, combined with access to modern technology, ensure that sugarcane cultivation continues to thrive. By balancing productivity, profitability, and sustainability, sugarcane farming remains a vital and resilient agricultural practice.